There's one box in the home nobody talks about, and yet every solar connection, every heat pump, every EV charger needs one. Yes, that extra little box, the size of a lunchbox, rammed in like an unwanted house guest, is plotting to invade the meter box. For decades, the meter box was boring, ugly, ignored, a cobweb hotel. But now it's centre stage. Extra consumer units crammed in, solar panels feeding it, heat pumps clinging on, smart meters spying. Can it cope with all this sudden fame, or will it crack? Because here's the thing, just like the electricity network itself, it's already cracking, groaning under the strain of our so-called electric future, and the best bit, nobody wants to fix it. So in this video, we'll throw in some solutions and maybe even a sprinkle of innovation. And if you want the powers that be, yes, those people, to finally notice, tell us your ideas for ending this meter box madness in the comments. So before we dive into our ideas for fixing this mess, let's recap on some of the chaos caused by this humble fiberglass cabinet. One grey area we wanted to clear up was this. Can you actually install a small consumer unit inside the meter box to power, say, an EV charger? So we asked every single distribution network operator in the UK. A few replied directly, and let's just say their message was crystal clear. Try it and you'll be metaphorically kneecapped. The rest, well, they caught wind of my cunning plan and sent a joint response through their trade body, the Energy Networks Association. And like most things that go through a trade body, it got watered down. Instead of a blunt absolutely not, it became a more polite not recommended. But there was a twist. They confirmed that the customer actually owns the meter box, which means if you do install anything in there and one day it stops them adding a smart meter or maintaining the equipment inside, you'll be the one responsible for ripping it all back out, which of course wasn't the straight yes or no answer electricians were actually hoping for. Instead, this so-called guidance was then dutifully repeated by the NIC EIC to their members and the wider industry. So the conclusion, shoving extra gear in the meter box is officially not recommended, and that doesn't exactly create a level playing field. Most electricians, loyal followers of this channel included, want to do the right thing, follow the rules and deliver the best job possible. But then they find themselves competing with others, often the very same energy companies who write the rules, who are more than happy to bend just a few of them just to get a quick job signed off for the customer. It's like being told to run a race while the referee's cousin zooms past you in a mobility scooter. The next big idea to solve the problem, a dedicated outdoor consumer unit. And despite myth and legend, no, I didn't invent it. A few electricians were already fitting them long ago when the EV rollout started. But then one manufacturer decided to go further, producing one in die-cast aluminium. Why? To make sure it actually lasted more than 5 minutes in the British weather and to give proper resistance to UV, unlike the usual plastic parts that turn yellow faster than a nicotine-stained net curtain, crack in the sun and end up looking like a broken deck chair. Of course, doing this properly takes care, the right IP rating, decent fixings, a neat cable route back into the meter box, the professional way. The cowboy way, clanging it to the wall and sealing around it with a tube of silicone you robbed from the window fitter, which works about as well as patching a roof with blue tack. Of course, as ever in this industry, the moment one manufacturer innovates, the others pile in. Suddenly, outdoor consumer units were everywhere. But here's the clever bit. To keep the liability squarely on you, they're not called outdoor consumer units at all. No, they're sold as garage boards. They just happen to be painted the grey to match your trendy window frames. Well, that's purely coincidence, obviously. The sudden rush to outdoor consumer units didn't go unnoticed. In fact, it caused some serious side-eye at the IET, which then prompted a fully blown technical article highlighting all of the things that you need to consider when installing an outdoor consumer unit. The irony, most of the items they listed are actually things the manufacturer should have sorted before sticking the product on the market with a nice shiny label saying for outdoor use. So beware, some of these boards might look like outdoor consumer units, but if they're sold as garage boards, well, the liability is yours, not theirs. And the article concluded rather grandly that many engineers would regard this as a method of installation as a last resort design option. Of course, last resort depends entirely on your point of view. Last resort if you're an electrician trying to compete with big energy companies who treat it as their first resort, unless they can wedge yet another box into the meter cabinet. Or last resort if you've just spent £7,000 on a used EV and want a home charger, but don't fancy rewiring the entire house. But the IET have spoken, and just to make sure the message was properly hammered home, the The guidance was mirrored recently by NAPIT in a very similar article. So once again, the liability ends up dumped right back on your doorstep, because in this industry, responsibility doesn't disappear. It just slides downhill till it lands on you. So let's take a closer look at a potential solution. Of course, this would only work if the DNO, the energy supplier, and the electrician are all involved in the conversation. If you think it's a good idea, let us know in the comments or suggest your own alternative. So what's in the meter box today? We've got the service head with the fuse, the one you never touch, the electricity meter, and in many installations, a double pole isolator, which is there so you don't need to pull that service fuse. It's the isolator that we think could be the starting point for a solution. But we also need to look at the other equipment electricians often have to fit in the meter box. There might be a switch fuse because the wiring regulations don't allow the service fuse to protect tails longer than 3 meters. There could be a set of Henley blocks to split tails and supply an additional consumer unit, like the outdoor ones we've already talked about, or in some cases, an extra consumer unit squeezed directly into the meter box. From an engineering point of view, this creates duplication. Multiple isolators, multiple connection points. It's messy and not always the most efficient approach. But the build-up of heat from the losses. When I discussed this with one DNO, they said their biggest concern wasn't just space in all of these components. A typical isolator has a power loss of around 3.6 watts per pole. So for a double pole 100 amp isolator, you're looking at just over 7 watts of heat. Add in another device like a switch fuse, and at full load, you've effectively created a 14 watt heater inside the cabinet. And that's before you account for any additional losses from fuses, connections, or the meter. So is there a better way? We think so. By applying a bit of joined-up thinking, that would mean the industry accepting that for many existing installations, the most practical location for connecting new technologies like heat pumps and EV chargers is inside the meter box. From there, the goal should be to develop a standardized, agreed solution, one that makes this process as simple and consistent as possible. Ideally, this could become an option installed during a meter upgrade or fitted by one of the emerging safe isolation providers. So what could this look like? Let's start by replacing the usual double pole 100 amp isolator with a double pole MCB. This would still provide isolation for the whole installation, but could also protect meter tails longer than 3 meters. It would also act as overcurrent protection, especially if rated at 80 amps, which helps address another issue seen in consumer units with solar PV inverters feeding in. We've covered that requirement in more detail in another video. You'll find a link in the description. Next to that, we could add a 40 amp RCBO to supply an EV charger along with a surge protection device. Altogether, the requirements for an EV charger, heat pump or solar connection could be met neatly within a 4-module enclosure, eliminating the need for extra switchgear or Henley box scattered around the installation. That still leaves one major challenge: terminating armoured cables. They're often used to supply remote consumer units, especially where mechanical protection is required and the cables aren't RCD protected. But there's rarely enough room in the meter box to terminate them properly. Installers have come up with all sorts of creative and sometimes questionable solutions, from using terminations designed for street lighting columns to homemade fittings. The problem is that these can leave exposed single insulated conductors between the termination and the switchgear. In our mock-up, we've used a small die-cast box positioned neatly below the plastic switchgear to terminate a 16mm squared 3-core SWA cable and the cable from the EV charger. It's a tidy, accessible and mechanically secure solution, showing how it could be done safely and within the space constraints. This is a mock-up that we've built entirely from standard components already supplied by Whitecliffe Circuit Protection. Manufacturers like Whitecliffe are already producing hybrid assemblies with the interconnecting bus bars for combining surge protection and isolators, and even special purpose isolators for dual tariff supplies. To bring our version of the solution to life, most of the development work would focus on the enclosure, integrating cable terminations with internal bus bars to link all the components cleanly and safely. When it comes to thermal performance, we've based our figures on the maximum power loss stated in the product standard. That's BSEN 60898-1 for miniature circuit breakers and BSEN 61009-1 for RCBOs. RCBOs. Using those values, a 100 amp double pole MCB produces around 6 watts per pole, or 12 watts in total. Add in a double pole RCBO for an EV charger at 2 watts per pole and another, say, for a heat pump, and you reach a combined total of roughly 20 watts of heat inside the meter box at full load. Now that's more than double what you'd expect from a standard 100 amp isolator based installation, but still less than the heat produced by some of today's installations where full consume units are squeezed into the meter box. Our concept would of course need heat rise testing to validate its performance, but it starts from a simpler, lower loss layout than the alternatives in use today. Compared with typical installations, this approach reduces the amount of equipment, cuts down on connection points, and still leaves valuable free space for future additions. We've managed to achieve all of this within a compact footprint, which could easily be expanded by a few extra modules to accommodate RCBOs for heat pumps, solar, or battery storage. So let us know what you think. Does it feel like a practical, industry-wide solution, or do you see a better approach? Tell us in the comments. We'd love to hear your ideas. And if you're planning to work inside a meter box, make sure you understand diverted neutral currents and other key safety considerations when isolating supplies. You can learn more about that in the video on screen now. Bingo.